In this video, we're going to be focusing on this chart on the bottom of page 90. We're going to assign oxidation and reduction numbers. Here is that chart blown up on the bottom of page 90, and we're going to need to use this information to figure this out. So I have all these elements, ions or compounds. I have manganese, I have a calcium ion, I have magnesium chloride, and I have water. I have overall charges. Why that is an overall charge, which is going to have to do with this particular chart, and if it has a negative oxidation number, I'm going to write it in here, and if it has a positive one, I'm going to write it in there. Let's take a look at the first one, manganese. This is an element, and it tells me on this chart that elemental forms have an oxidation number of 0. So the overall oxidation number is 0. The reason is it's the elemental form. So neither of these are applicable. Right? I can't do either of those, or they don't matter. And that takes care of manganese. Let's move on to this calcium ion. So I have Ca2+, so that's an ion. That is an ion. So here, at atomic ions, it tells me the oxidation number is equal to the charge on the atom for monoatomic. Mono means 1. I have a 1 atom ion, so the overall charge is +2. The reason for that is it's an atomic ion, and it's the charge on the atom. This is a positive, so there's no negative, and the positive oxidation number is +2. Sorry, I didn't talk there for a little bit. Alright, now we're going to take a look at this one, because this one is different. It's not just it's a compound, so we have a little bit different stuff going on here. If I take a look at this, there's no charge on that, therefore it's a neutral compound. The sum of the oxidation numbers of the atoms or ions in the neutral compound has to equal 0. So the overall charge is 0, and the reason why is because it's a neutral compound. Now we're going to actually have positive and negatives together. So the overall charge on this has to be 0. We already know that. We learned that when we did ionic compounds. If we take a look here, our group 2A, Mg, is going to have a positive 2 charge, which we already know. And this chlorine is acting as an ion here, and you know that they have -1 charges. So the negative oxidation number here is going to be on the chlorine, and it's 1 negative, and the positive is magnesium, and the oxidation number is going to be +2. The last one is going to be very similar to that. This should feel familiar because this one is ionic, and it's very close to what we did when we dealt with ionic compounds. Well, it's identical really. But this one is covalent. Alright, we have 2 nonmetals. So it's covalent, and they still can get charges. They still have oxidation numbers. So if we take a look at H2O, it is also a neutral compound. So the overall charge is 0. The reason why is because it's neutral. Now let's take a look. The overall charge on this has to be 0. Hydrogen, when bonded to a nonmetal, has a positive 1 charge. See here, hydrogen +1 when bonded to a nonmetal. Oxygen is a nonmetal, so that means hydrogen has a +1 charge. This oxygen is not a polyatomic peroxide, so it's going to have a -2 charge. Now this makes sense because I have 2 hydrogens, right? So that means I have a total quantity of +2 to 2 negatives, so the overall charge is 0. My negative oxidation number is on the oxygen, and it's a 2- oxidation number, and hydrogen has an oxidation number of +1.